This is extra credit to by Zara and Amir. We predicted for the 90-degree cones that the larger the surface area, the longer the drop time, and the rate of increasing magnitude is progressing the slowest. For this first graph, position over time, acceleration is the slowest due to large surface area on air resistance, which applies a force opposite the direction of travel. Acceleration isn't constant, acceleration being the slope of this v versus t graph. Acceleration is decreasing over time, therefore the slope of the curve approximates a horizontal line as time accumulates. The linear fit doesn't quite account for the initial data. It starts to fit as time increases and acceleration decreases and coming closer to constant value, which means no change in velocity. A double cone at 90 degrees, velocity increases as well as mass, bringing the total acceleration due to air resistance down for an overall faster drop time than the single 90-degree cone. Increase in velocity and decrease in overall acceleration due to air resistance, but overall acceleration is increased due to increase in mass. Acceleration remains dynamic and is decreasing over time. The curve resembles a horizontal line, which suggests the cone is approaching terminal velocity. We continue to see an increase in mass and decreasing effect of air resistance in position and velocity. The linear fit wasn't a good fit for the situation, which had a dynamic acceleration. This is the triple cone at 90 degrees. Velocity and mass increase. Velocity is near constant towards the end. Acceleration is decreasing in downwards direction towards constant of 0. We continue to see an increase in mass and decrease in effective air resistance in position and velocity curves of the object. Linear fit wasn't a good fit for the situation, which had a dynamic acceleration. This is quadruple 90-degree cone. Velocity and mass are increased. Velocity is near constant towards the end. Acceleration is decreasing in downward direction towards constant of 0. We continue to see an increase in mass and a decrease effect of air resistance in position and velocity. Linear fit wasn't a good fit for the situation, which had a dynamic acceleration. This is a single 150 cone. V increased faster, so overall acceleration decreasing slower. This cone didn't fall straight down like the 90, instead it traveled at an angle landing to the right. Also increased velocity compared to the single cone due to less surface area and mass. Less surface area and less mass proportional to less acceleration due to air resistance, so overall greater acceleration. Decrease in mass. This is the double 150 cone. Decreasing mass and decreasing surface area had the intended effect of falling faster. Less surface area and mass proportional to less acceleration due to air resistance, so overall greater acceleration. We continue to see an increase in mass and decreasing effective air resistance in position and velocity curves of the object. Linear fit wasn't a good fit for the situation, which has dynamic acceleration. This is a triple 150 cone. Vertical position over time, decreasing mass and decreasing surface area had the intended effect of falling faster. Less surface area and mass proportional to less acceleration due to air resistance, so overall greater acceleration. Increase in mass and decreasing effective air resistance in position and velocity curves. Linear fit wasn't a good fit for the situation, which had dynamic acceleration. This is the last quadruple 150 cone. Decreasing mass and decreasing surface area had the intended effect of falling faster. less surface area and mass proportional to less acceleration due to air resistance, so greater acceleration. We continue to see an increase in mass and decreasing effective air resistance in position and velocity curves. Linear fit wasn't a good fit for the situation, which has dynamic acceleration. Overall, reduced air resistance, then mass, and therefore increased overall speed and decreased time of fall. This is the data that we collected for each cone. You can see that the values for the 150 cone were less than the overall values for the 90 cone. Average velocity increase for the 150 cone, as well as acceleration in the negative direction. Thank you very much.